Welcome, this is 12.3 that we have right here, and we're going to be talking about inscribed angles. So write the definition right here. An inscribed angle is an angle whose vertex is on a circle. So if I'm looking at this picture right here, that vertex right there is on the circle, and we have this theorem right here, and our theorem is that the angle is going to be 1/2 the measure of the arc. So again, here's my arc that I have right here, and if that arc, for instance, was 100 degrees, then all we have to do is just cut this in half, and that would be 50 degrees that we have right here. So again, make sure that you have this theorem right here and that definition, and let's move on. We have a couple corollaries that we have right here. Again, using that same theorem, there's a couple things that we know. The first one is two inscribed angles that intercept the same arc are congruent. So again, if you're looking at it, if these two angles have the same arc, well, it means that the inscribed angles have to be the same measurement. That would make sense. The next one says an angle inscribed in a semicircle is a right angle. And again, if I'm looking at the arc that we have right there, if that arc is 180 degrees, well then obviously half of 180 would be 90, so it would make it having a right angle then. And then the last one says the opposite angles of a quadrilateral inscribed in a semicircle are supplementary. So it means that these opposite angles right here, in this case D and B, when I combine D plus B together, that they are going to equal 180 degrees. And the same thing would be true with angle A and angle C. Okay, so make sure you have all that written down, and let's do a few problems. Alright, problem number 1 that we have right here. What are the values of A and B? Okay, so again, if I'm looking at this first one, I have this angle A that I have right here, that's the arc length, and I have angle B, which is that inscribed angle one. So I'll kind of zip through it, so it'll kind of show us a little bit as we're going through. Again, if I'm looking right here, the inscribed angle, angle 60, is applying to that angle A that we have right here. And so to be able to figure that out, what we are going to do is we are going to basically take that and multiply it by 2 in order to get 120. So let's have you guys write down these two that you have right there. That would be great. And so now that I know that, and I'm trying to look for the inscribed angle, angle B. Well, angle B, that mark goes from there to there. So that's what I'm trying to find, that whole arc. And we just found that that arc from PT right there is 120. But it's not only that, it's plus the 30 that we have right there. So again, what I'm going to do is I'm going to take those two arcs, I'm going to add them together, and then I'm going to cut them in half in order to figure out what that inscribed angle is. So we are going to take half, and that's going to give me the inscribed angle of 75. So let's have you guys just write those two down. So the problem, those two, and the picture, and that is awesome. Go to the next one. Alright, here we go. So it says, what is the measure of angle 1? So if I'm looking at this, well, the arc length from this inscribed angle, if I go from here all the way to there, because that's where the inscribed angle ends that we have right there, well, that's a semicircle. And we know a semicircle is 180 degrees. And again, remember my formula is we're going to take half of it. So we know that angle 1 right here is going to equal 90 degrees. So remember, that was one of my corollaries, that if the inscribed angle, if the arc measurement is a semicircle, then again, half of it would be 90 degrees that we have right there, a right angle. And the next one, similar, it says, what is the measure of angle 2? So if I'm looking at this, I'm given a couple different things. Well, I see I have this inscribed angle of 38. And again, if I'm looking at the arc ends there and goes to right there. And again, remember, it's half of it, so this arc length would be 76 degrees that we have right here. So if I'm trying to find out what angle 2 is that I have right there, if I'm trying to find out what angle 2 is, here's this inscribed angle that we have right here. Well, we notice that it is the same exact arc length, which is 76. So if I'm trying to figure out what angle 2 is, angle 2, if I take half of 76, is going to equal 38 degrees. So again, remember this was one of our other corollaries, which said that if two inscribed angles are facing the same arc, then both of those inscribed angles are going to be congruent. In this case, yes, they are congruent. They both equal 38 degrees. Alright, here we go. Our last one that we have right here. It says, in the diagram, SR is a tangent to the circle at Q, and it wants to know if PMQ is 212, what is angle PQR? So if I'm looking at the first one, remember when I list 3 on an arc, it's going to be a major arc that we have right here. So if I go PMQ, that is going to be this that we have right there. And all that right there is going to equal 212 degrees. So if we are trying to find this inscribed angle that we have right here, to find out what that angle is, we would take 212 and we would divide that by 2, or multiply that by 1/2. 212 divided by 2 is going to give me 106 that I have right here. So this angle right here is going to be 106. And again, do you see how we have a straight line right there? And we know a straight line adds up to 180. And so what we are trying to find out is what that angle is right there, which is angle PQR. So we know then that to find out this, that when we take 106 and we add it with x, it's going to equal 180 degrees. So when we take 180 minus 106, we're going to get x is going to equal 74 degrees that we have right there. And that's it that we have right there. Alright, see you guys later.